we'll have another virtual talk by Vittorio Lumare. So Vittorio got his master's at Politecnico di Milano, Italy, and is a robotics engineer with 12 years of experience. After his master's, he began research and development in indoor positioning robotics and many other projects around Italy and the UK, working mainly with Moli Robotics. He's now a freelance consultant in robotics and computer science, working for both local and remote clients, and started his personal open source project, Rebelia, an open source robotic hand for humans and robots, which he will now share more about today. Please welcome his virtual talk titled Rebelia, a hand for humans and robots.
I am Vittorio Lumare, a robotics engineer, and I started this project of developing a myoelectric hand because I have a friend which has a transradial amputation, and he explained me he couldn't afford advanced myoelectric hands with many degrees of freedom sensors because they cost too much, they are bulky. The only one, the national health system in Italy, the only myoelectric one which is given to the people by the system for free is very old and not advanced at all. It has only 1 degree of freedom. So we started to check if it was possible to make a better hand with low cost, because now the technology it's very cheaper than before. There are products ready on the market. You don't have to invent one motor. You can reuse some servo motors that already exist. So we started trying, and we ended up with one design which can it's compatible with his amputation, because depending on the length of the remaining limb, you have less or more space. So in this case, he had this space. We put in this part all the electronics and actuator we needed, and all the rest is just tendons and plastic part pulled by the tendon. So we ended up with a mechanical design, very simple. It has one tendon for closing the finger and another tendon to extend. We made a lot of research and tests to prevent lateral movement. We only want to move it forward and be rigid in all the parts except the flexible joints. And also we made in a way it's easy to replace covers. We can have covers on it. This is the new version actually. There are 2 versions. The first one has been already released, open source, and the next one will be done soon when it's finalized. We had to improve many things to make the device usable. The device has 2 sensors. I can show here, it will be shown even better afterwards, but it's just the first prototype we made. It has 2 sensors inside, and this sensor can detect the muscle movement of the flexor of and extensor of the wrist. So when you use the flexor muscle, it will flex the wrist. These people don't have the wrist. They are only the remaining muscle, but these 2 muscles often are still active, despite this kind of people often loses the control of all the other muscles. So depending on how many muscles you have a better control or a simpler control. My friend had just 2 muscles available, the closer one and the flexor one, the extensor one, sorry. So we put 2 MG sensors, electromagnetic, myographic sensors. So they are just external, put on the finger, on the skin, contact sensors. They don't need liquid or any treatment of the surface. You can just put them on the muscle always in the same place and position, and they will detect the muscle activity. We put on the closure, one on the extensor muscle, and when the closure muscle activates, the hand starts pulling with the servo motor the tendon which close the finger. As soon as you start doing the opposite, activating the opposite muscle, it starts going back until you stop doing anything. So for example, if I want to grasp an object, I have to exert some force on this muscle, the flexor muscle, and it starts closing, and at some point I stop doing anything and the hand will keep the grasp. And this is useful because the people don't want to keep exerting force while grasping an object and moving it. They want to just close, stop acting, stop moving muscles, and the hand must keep the grasp. This works very well. We tested it, and there are two thresholds, with one threshold for closing, one for opening, and this is applied to all the fingers simultaneously. If some person has more muscle available, we can add more MG sensors to control independent fingers as well, as we already can see with many advanced myoelectric hands in the commercial field. But this kind of hands cost a lot. Not many people can use them because they don't have so many muscles available. Whenever this happens, we are ready to integrate more sensor in our version, which is low cost. So instead of having a hand which costs 20,000 euro, we can have a hand which costs 5,000, and the actual cost of the components is only 200 pounds and another 200 of man work. So it's a very cheap device. The reason why it costs a lot because the certification, the regulations in Europe is called MDR. They force the companies, it's right, I mean, it's required because they have to implement many procedures and checks and external audition in order to be able to deliver a product which is always the same, with the same characteristics, with the same safety measures. And so to have a reliable and safe medical device, the cost is a lot, because this certification cost more than 40,000 initially, euro, US dollars, pretty much the same. And then you have another expenses for the insurance and so on. So the price of a hand triplicates due to this. So people, also company want to get more earning, and so the price increase. In all this scenario, we thought we can reduce at least the engineering cost and some earnings for the company. So we have a product which it still gives promises to the company a successful business, but with reduced cost. And because we release open source, the engineering cost now is solved, already done for everybody. Everybody can get and start it. You can sell it as well. It's not non-commercial license. You can also sell it. So anybody in the world can create, print this hand assembly and then sell or give for free. And we are okay with this because the intent is to make the market so competitive that anybody can do easily the hand, and all improvement must be shared because it's a viral license. So you want to do it, you have to release it. You want to improve it and make money with it, you have to release it. You do something which improves the hand so much, everybody will get this because you must release it. And then so we will end up having very advanced robotics hand in all the world, and everybody can do, many companies will be able to do this, and the price will go down very much. So this is the intent of the project. The device works, we tested many ways. We also made some effort for conditioning the signal, because there is a much noise to detect the muscle activity, and usually there are many steps. You do convolution, you do the envelope. We ended up with an FFT filtering which isolates the band that we need, and then with some thresholding we could obtain a signal and a reliable control. So when my friend, which tested the hand, this was made for him, unfortunately he cannot use it anymore because he made some gym and his arm grew a bit, doesn't fit anymore. But he can control very well, and when only he decides to close the finger, they close, and if decide to open, they open. If he doesn't want to move them, they don't move. So we tested many times. It's reliable. There are two batteries inside in this panel, and now there are screws to remove. We're gonna make the next version more easy, so you don't have to use screw to remove the panel and replace the batteries. And so we made a new model. It's not released yet. Will be. It has all these advanced features. You can remove the plastic very easily and put them back. And also this part, if you want to maintain the tendons, do some change, it's very easy. And also you can change the color, and you can change the color, everything. And so this is very versatile project, and after the signal conditioning and all this improvement, we tested it, and I have to say we were surprised by the result. And so we started thinking we can start distribute in some way, but the regulation makes this impossible, because you have to do a very expensive process. And then we started to concentrate on the robotic version without the socket, only for robots, to get a product at low price without all this regulation and costs, with the intent of improving it and obtaining a successful business which can produce earnings and give us the possibility to be on the market, to be positive in business. And so this should help to obtain a reliable product in a few years with earnings which permit us to also start the other project, the prosthetic version, which now it's impossible, at least for me and my small team. So the intent is to have two products, the robotic products and the prosthetic one, both open source, both you can do, improve, copy, sell, whatever you want. We will do the same. Everybody, we hope, will do the same, and so we have many versions which will probably converge into a very advanced one, which anybody can still get and produce and sell. So this is a solution which is effective. My friend used it. It could grasp many objects. Could open a bottle of water. Perfect. It could open a door, pressing buttons, grasping objects very reliably. But in order to get this, we had to do several improvements. And the most important one we discovered was the grip. So having a hand which can close reliably and you can control it reliably, and you can decide I want to close it more, a bit less. It's good. It adapts to the object because it has tendons, not gears. So it basically closes until it touches all the part of the object. It's closing over it. But there was a big problem. The object tends to slip. There was no grip. So our skin has a very good grip. Many robotic hands are made of silicone, which is the best material for the grip. And so we had some pads on the hand, initially of rubber in the first prototype. And the current one, you have to glue the rubber pieces to the palm, to the fingertips, and you have a very good grip over the objects. This helped us to grasp an object which couldn't be possible. Even object large like this, like 15 centimeter diameter. So it's a big hand. I made it over my friend's hands and mine, which are basically the same size. So it has a size. We plan to make it of different size, obviously. And in the new version, we will use silicone pads, which cannot be printed at the moment, or you can with some special printers. It's not easy to have this kind of equipment. So we made in a way that anybody can do. And we print the finger with the TPU, flexible. It has flexible joints with also PLA inside materials to make the print more solid, to prevent some distortion of the finger. So it can move only in one way that we want. And then the final material is cast by manual injection molding. So we prepare a cast and then put exactly, it matches the face of the front of the finger we wanna produce, and then inject with the syringe the liquid silicone, and then it solidify after some hour. And this is the most advanced kind of piece we made for this hand, and it will be delivered in the new version. The version number 2 is not yet delivered. We have to improve it. But the expectations are good because our test prove it works very well, and we will put even more features, and all will be released by open source. So we will have we can anticipate we will have a hand which can auto calibrate, which can limit if the temperature raises too much, preventing risk of burning, risk of fire, risk of damaging the motors, and also limiting the maximum tension for the tendons, preventing the breakage, the uncalibration. Even though the hand will calibrate anyway automatically every time you start it, sometimes it may need some manutention, some maintenance. So you have to open the back panel and register some tendon after some months of usage. And to make this even easier, we made all snap fit, so there are no screws to remove. You just remove by pressing, the plastic pops up, and you can maintain the hand. In the rarely times is needed, because again, the auto calibration and the force limitation will make sure there will be no need so much of doing this. It will happen very rarely. All this system we made, this control, also provide another good functionality, that you can grasp objects without knowing the shape, and the hand adapts to the object automatically, stopping the force exerted by each motor when it surpasses the threshold that we want. So if at some point I want to pick a very fragile object like an egg, I just have to set the limit of the force lower to the minimum level, and the hand will start closing around the object. When it feels a bit of resistance, it will stop suddenly. And I can choose different levels of closure strength, up to the maximum limit over which one it will create problems for the hand integrity. So we cannot go over the threshold, but the threshold is very high. So the hand is strong, it will be durable, auto-calibrated, and I hope this will be appreciated, and many people can contribute to this project to make hands even more accessible in all the world. Thank you for watching. Bye.